Now let us see some questions related to the number system. The first question, you have to find the sum of these two decimals. Now what if your decimal looks like this? Then it is very easy. How do you express it as a rational number? Whatever you see in the decimal place, that will come in the numerator and in the denominator. Which power of 10 will come? Count how many digits there are. That power of 10 will come in the denominator. So suppose here instead of this you have 2, 3, 4, then this raised to 3, or in other words 3 numbers are coming here. So 10 raised to 3, or in other words you will have 1000. But then that is not the number you have here. What is the number you have here? It looks like this. It goes on and on and on. Or in other words, what is it? We can write it like this. Now how will you express this as a rational number? Whatever is coming in the decimal place, whatever is getting repeated again and again, write that in your numerator. And how many digits are getting repeated? Only 1. That many nines you have to write. So for example, if this is 0.234, it keeps on repeating 0.234, 234, 234, it keeps on repeating. Then how will you express this as a rational number? Whatever comes in the decimal place, write it as it is. And how many numbers are getting repeated? 3 numbers are getting repeated. That means that many nines you have to write. This is how you write it in the rational number form. So now, what is your question? What is getting repeated? 2. How many digits are getting repeated? Just 1 digit. Plus this is what? 5 by 9. So your answer is what? 7 by 9. This is your answer. What if you had to multiply both of them? Then your answer will be 10 by 81. Now look at the second question. We have to find an x whose square will be irrational, but then when it is raised to 4, when it is multiplied 4 times, it becomes rational. Now consider any number which looks like this. This is irrational. How will you make it rational? How many times do you have to multiply it? This is just another way of writing this, right? This is just the 7th root of 8. Now how will you make it into a rational number? If you raise it to the power 7, you will get 8, which is what? A rational number. But remember, anything less than 7 will still be irrational. Raised to 2, raised to 3, raised to 6, everything will be irrational until you come to 7. You have to raise it to the power 7 to get a rational number. Now look at the options here. This raised to 2 will become rational. This raised to 3 will become rational. This is your answer. Until you raise it to the power 4, it will remain irrational. You have to raise it to the power 4. Until then it will remain irrational. So this is your answer. What about this? This is also irrational. If you want to make it rational, what will you do? You will raise it to the power 5. Then you will get this. Then you will get the answer 6, which is a rational number. So your answer is this. Its square will still be irrational. You will have to raise it to the power 4 to make it rational. In between two rational numbers, what happens? I have randomly taken two rational numbers, 1 by 4 and half. 1 by 4 is 0.25 and half is what? 0.5. Now, given these two numbers, between these two numbers, you can find any number of rational numbers. How does your rational number have to look like? It can terminate, or if it does not terminate. What does terminate mean? There, finished. It stops here. It does not terminate means what? It goes on and on and on. But then what should it be? It should be recurring. It should be the same thing happening again and again. Such numbers are called rational numbers. Either it terminates, If it does not terminate, it recurs. And this is what? This is irrational, because it is not coming, it is not terminating, but it is not repeating itself. Each digit is a surprise. You cannot guess what is the next digit going to come. So given any two rational numbers, infinite number of rational numbers, infinite number of irrational numbers also. Now look at these two options. Both of them will seem correct, but look at the answer very carefully. One says infinite, other says many. Many does not mean infinite. In between two rational numbers, what you have is infinite rational numbers, infinite irrational numbers, not many. If I say I have many friends, it does not mean I have infinite. So the correct option should have been infinite. It is not there, so this is not it. This is your correct answer. Look at the fourth question. You have a product of a rational and an irrational number. What will it be? Can you for sure say it is an integer or a rational number or all of this? Now let us see what happens to your rational numbers. Your rational numbers will always be closed. Closed means what? If you take two rational numbers and add, the answer will be a rational number. Subtract, again same. Multiply, again same. You carry out any of these three actions on rational number, the answer will again be a rational number. Then what will it not be closed under? It will not be closed under division, because you see here such a thing does not work. What if the denominator is 0? So except for division, if you have any two rational numbers, remember their sum, their difference, their product will all be rational number, or in other words it will be closed. What if you take two irrational numbers? You cannot guarantee anything. See, I have taken two irrational numbers and I have added them, answer is rational. I have subtracted them, answer is rational. I have multiplied them, again answer is rational. Division, again rational. So if you take two irrational numbers, add or subtract or do whatever, there is no guarantee that your answer will be irrational. Look at this. We have got a couple of rational numbers as answers. You do not have anything to the square root or cube root. You do not have it. So now that you know how rationals and irrational work, what if we take one of each? One is rational and the other is irrational. Then what happens? See, what answer do you have? Each one is what? Each answer is irrational. So what is your answer? C is your answer. Now look at the first question. What do we have to do? We have to express this decimal number as what? As a rational number, something in the numerator, something in the denominator. How is it different from the first question we did? In the first question, this part, the whole number part, there was just 0, but here you have a number. Then how do you do it? Now the denominator is same. Whichever number is getting repeated again and again. How many numbers? Just 6. 6 is getting repeated again and again and again. So that many 9s you have to put here. If 2 numbers are getting repeated, then 99. 3 numbers, 9, 9, 9, 3 9s. Here there is just one number getting repeated, so your your denominator is just 9. What about your numerator? Write both of this together as one number and subtract the whole number part from this. You will get 15 by 9, or in other words you will get what? 5 by 3. Now I'll just write down one more example in case you want further clarification. So here, how will you write this as a rational number? Look how many numbers are getting repeated again and again. 735, 735, 735, 3 numbers. So that many 9s in the denominator. What will come in the numerator? Write them together as one number, 2735, and subtract the whole number part from it, and that is your answer. Take out your calculator, divide these two numbers in and see if you get this answer. Now look at the next question. It is about the decimal expansion of rationals and irrationals. Forget rationals or irrationals. Take any decimal expansion. How many types will be there? There will be two types. Either it will terminate finished, or it will not terminate. It will go on and on and on. So these are the only two main classifications. Either it terminates or it does not terminate. Now, if it does not terminate, there are again two classifications. It is recurring, the same number happening again and again, or it is non-recurring. So your rational numbers are what? They fall in these two categories. Either they will terminate, finished, or if they do not terminate, they will be recurring. And the last option, the third option, is for irrationals. Now look at this question. Decimal expansion of rationals is terminating. It is only partly true. It is in some cases it will be non-terminating and recurring. So this is wrong. What about the second one? Decimal expansion of rationals is non-terminating. Again wrong. It can be terminating. So your last one is the correct answer. Decimal expansion of rational numbers is what? Only it falls in these category. It will be non-terminating and non-recurring. Now look at the next question. You want a rational number between what? Root 3 and root 2 and root 3. What is root 2? It is 1.4 something something. And then what is root 3? It will be 1.7. Between these two numbers, which do you see? Here. This is your answer. Now look at the next question. What do you see here? Which of the following is irrational? This is what? Square root of 4 by 9 is equal to what? This is 2 by 3. What about this? Now the square root of 12. This is 12 is actually what? 4 into 3. Now you can take 2 out and there. These two gets cancelled and this answer is actually just 2. This is 2. This is 2 by 3. And what is root 81? Root 81 is 9. So what is the only number which is irrational? It is this number. Remember, square root of any number which is not a perfect square. That means leave out numbers like 1 square, 2 square, 3 square, 4 square, 5 square. Leave these numbers out. Other than that, any other number you take their square root, then that will be irrational. Again, take the cube of these numbers. If you take the cube of any other numbers other than which is a perfect cube, for example, take any number in between this will be what? It will be irrational. And how will you make it rational? You have to raise it to the power 3. Only then it will become rational. Till then it will be irrational. Now look at the last question. What do you do with this? Nothing at all. One is square root of 5 and the other is square root of 3. There is nothing more to be done here. But then remember, this was also square root of 5. Then just think of it as 4 oranges plus 5 oranges. Square root of 5, you see same here. You can take this out and just add this and write. This will be your answer. So please remember, you cannot do anything to this. Square root of 5, square root of 3, you can do nothing while adding or subtracting. But remember, if you are multiplying, then what will you get? You can very neatly put both of them together and write square root of 15. Now look at this question. What is irrational? What do you have here? It is recurring, same number coming again and again, which means rational. Again here it terminates, which means what? This is also rational. What is the only one left? Look at this. It does not terminate, neither does it recur. You cannot guess what will come in the 10th place. You cannot guess what will come in the 15th place. It is not the same block coming again and again. So this is your irrational number. Now look at this one. Which of these 4 options is actually just X? square. Now remember one thing, you do not have any rule which looks like this. Please remember that what the rule is, 1 base, 2 exponents. That is what your rule is about. This is a raised to m by a raised to n. This is a raised to m into a raised to n. Remember, it is 1 base and both the exponents together. You do not have any rule which looks like this. So this is going to stay just like that. There is no rule which looks like this. And now look at the next option and tell me what is a raised to minus m and a raised to 1 by m. What is the difference between these two? Or in other words, what is the difference between 2 raised to minus 3 or 2 raised to 1 by 3? What is the difference between these two? If your exponent is minus here, it means 1 by a raised to m, or here it means what? 1 by 8. But what does this mean? This means, or here it means the cube root of 2. So please remember this and we will see what this means. Now look at this. This is the 12th root, which is 1 by 12 into, there again a 1 by 3 and a raised to 4. What do you get? So this will be your answer. 4 as it is, a 1 by 3, a 1 by 12, and then all of this get cancelled, and this is actually x raised to 1 by 9. And what about the next one here? A 3 here, a 2 by 3 here, a 1 by 2. If there is no number here, it actually means 2. So a 2 here, everything gets cancelled and you get what? X. Still not the answer we want. We want an x square here. Now look at the next one, a raised to m into a raised to n. What is it? It is a raised to m plus n. So this means what? X raised to 2 by 4 plus 6 by 4, which means x raised to 8 by 4, which means what? X square. So this is the answer we want. We are using the same set of laws. Laws for what? Laws for your base and your exponent. Using the same thing but in different forms. 16 is what? 16 is 2 raised to 4. Whenever you have numbers like 16 or 9 or 25, always reduce them to the powers of any prime number. If you see 27, write it as 3 cube. Always bring it to the prime number. So instead of 16, write it as 2 raised to 4. Then what? A minus 2. Then what? A 1 by 4. Then cut all of that. You will get what? 2 raised to minus 2, which is 1 by 2 raised to 2, which is what? 1 by 4. Now the same thing with the next question also. 1 by 3, 1 by 4, multiply all of them. Just one base, then all of these exponents, then this is what will happen. But remember, it is different when you have something like this. Then you will have to add the exponents. When you have something which looks like this, which is what? 2 cube plus 2 raised to 5 will be 2 raised to 8. Now this is different to what you have here. It is 2 raised to 3 raised to 5. Now we come to the last set of questions. What do you see here? You see 256. Bring it to a prime number. Don't stop at 16. Don't stop at 8. Bring it to 2. You have 256 is 16 square. But what is 16? It is 2 raised to 4. So therefore you have what? You have 2 exponents. Multiply them and then you get what? Instead of 256, you can write 2 raised to 8. Wherever you see 256, write 2 raised to 8 and 0.09. What is that? 9 by how many decimal points you see here? 2 decimal points. So instead of 0.09, write 9 by 100. Instead of 0.16, write 16 by 100. Again you have in what form? A raised to m into a raised to n. So what do you have? You can add both of the exponents. When you add 9 by 100 plus 16 by 100, you get what? 25 by 100. Again, using the law of exponents, your answer will be what? It will be 2 raised to 2, which is 4. Now look at this question here. What is the problem with this? In the denominator you have an irrational number. That is not acceptable. Having irrational number in the numerator is fine, but not in the denominator. Why is that? When you have to add two fractions, you will see that when you take the LCM, you take the LCM of what? You take the LCM of the denominators. So your denominators should be free of any irrational numbers. They can be in the numerator. The numerator is fine, but your denominator must be free of any irrational numbers. So whenever you see something like this in the denominator, get rid of it. How? By finding its conjugate. If you have a term which looks like this, instead of plus put minus, that will be its conjugate. Then what will come in the denominator? Square of this. It is just a plus b into a minus b. What is a plus b into a minus b? It is a square minus b square. That is all there is to it. When you multiply any term with its conjugate, you will get the square of this minus the square of this. Now what is the square of root 3? It is 3. Square of 1, 1. Then in the denominator C, you have got a 3. Good news, right? But then when you multiply the denominator with the conjugate, you have to do the same thing to the numerator. Then you have got a square here. Now don't rush to open the square. You know that a minus b the whole square is what? A square minus 2ab plus b square. You know all of that, but do not rush to do that. Why? Because you see the square root here. That is the problem. If you keep something like this, just keep it like that itself. Why? Because when you open it, you will get like this and cut, and then you will get just a. So you see what is happening here? Something raised to 2 and then a square root outside, that is going to get cancelled. So all you are going to get, this is in your numerator. What will you get in your denominator? This. But then that is not all. We have to find an answer for it, right? Now what is this? They have given square root of 3 is what? 1.732. That minus 1 will be what? This will be your numerator. And what about your denominator? Square root of 2 will be 1.414. Look at all these options. Do not start multiplying or dividing when you are in MCQs. At the maximum, you are going to get what? 1 mark. Why bother doing all of that? Just take an intelligent guess. This is what? It is 0.7. And what do you have here? It is 1.4. Which means what? This is the same as 7 by 14. Which is the same as 1 by 2. Which is the same as 0.5. Look at which option comes closer to 0.5 and go with that, which is what? This. Now look at the last question. Here you have a 2. Here you have a 2, but here you have a 32. 32 is what? It is 2 raised to 5. But before you rush to do that, just look at your options. You have the same number here in one of the options in A. So do not rush to break it down into its prime factors. Let us just see what happens to these two. This is 2 raised to 1 by 3 and an into sign and a into sign here, then here, then here. Then what rule will you apply? You will apply a raised to m into a raised to n is equal to a raised to m plus n, right? So therefore what will you have? 2 raised to 1 by 3 plus 1 by 3 is 2 raised to 0, which is 1. So this whole part becomes 1, which means what is left? Just this one, which means this is your answer.